students, in the last few sessions you have dealt with p block elements. You had group 13 and group 14 elements, study of the compounds of those elements in your first year PUC. I hope you can remember all those facts there. One of my colleagues has done the sessions on group 15 and group 16 elements, the compounds which come under those category of elements. I hope you are clear with all the concepts whatever she has told in her previous sessions. So today in the new session I would like to continue the same group of elements, that is p block elements. I shall take upon group 17 elements. Students, you already know that group 17 elements are also called as halogens. Now, why are they called as halogens? See, halo generally means salt and gens means born. So, they are generally salt producers and hence by the name halogens. You also have studied in your very first PUC that these group 17 elements are highly reactive, isn't it? Yes, they are highly reactive. Why? Because they have a tendency to accept the electrons. So today we shall discuss in details group 17 elements, the periodic properties, chemical properties, as well as some important compounds which come in group 17 elements. So prior to this, we shall start with the occurrence, how exactly they are available in the earth crust. So the very first point is something on occurrence, where do we find them? So prior to that students, I would like to name the halogens whichever are present in group 17 elements. You know that the periodic table is classified into 18 groups and 7 horizontal periods or horizontal rows which are called as periods, isn't it? Now, who are the members which come in this group 17 elements? To list out the members, I have first comes fluorine with the symbol F, next chlorine with the symbol Cl, next bromine, Br, iodine, I, and last astatine, A, T. Now students, in this astatine is radioactive. Okay. So our study will be limited only till iodine. Since astatine being highly radioactive, the study is limited. We don't study this astatine. Now I have fluorine, chlorine, bromine and iodine, the members of halogen family. We shall see their occurrence now. Now generally seen students that fluorine and chlorine, they are seen in bit large amounts. You can see them in excess, but bromine and iodine are generally seen in less amounts. Now we shall see the occurrence of these elements one by one. So first comes fluorine. Fluorine, this is generally seen as insoluble salts, usually seen in the form of CaF2, calcium fluoride, cryolite, Na3, AlF6 and fluorapatite, Ca3, PO4, twice CaF2. So these are the three major salts wherein which we find fluorine. Small amount of fluorine is seen in teeth, okay, human teeth or animal teeth, something as such. Chlorine. Next, if I move on to chlorine, students, chlorine, you know that majority of chlorine is found as chlorides. Where do we see that? Usually in seawater. So seawater generally contains chlorides, bromides and iodides. All of them are present in seawater, but majorly we find chlorides. So the chlorides are sodium chloride, you may end, majority is sodium chloride. You have studied the preparation of sodium chloride in first year PUC from evaporation of seawater. I hope you recall those things. And next one is carnallite, MgCl2 KCl along with 24 molecules of water. So these majorly chlorides are this one. So bromides and iodides, they are present in very small amounts. So some I can end up with the sodium iodates can also be seen. So this is regarding occurrence. They are usually fluorine and chlorine are found in large amounts, while rest are found in small amounts. As the time being radioactive, half-life being very, very less, the study is limited to this. So this is regarding the first point regarding on occurrence. Next we shall move on to the electronic configuration. That is, in general we shall focus on some of the atomic properties, that is periodic properties like atomic size, ionization energy, electron gain enthalpy, etc. as such. Okay. Fine. We shall move on to the second one, electronic configuration. Students, you already know to write the general electronic configuration, isn't it? So the general electronic configuration of P block that accounts to be NS2 NP 1 to 6. This is in general for P block. Now this group 17 elements are the elements which come in the P block containing 1 electron less to the noble gas configuration, and hence the general electronic configuration will be NS2 NP5. So how many electrons are present in the valence shell now? If you count 5 plus 2, 7 electrons are present in the valence shell, or you can say that these elements have 1 electron less than the noble gas configuration, which makes them more reactive. So this is regarding general electronic configuration I have mentioned. If you want to write the individual electronic configuration of all the elements, so it is very easy. You can write for fluorine. So I have the noble gas core of helium. So fluorine comes in the second period, and hence I have 2s2, 2p5. In the same way, if you want to write for chlorine, helium, next comes neon, 3s2, 3p5. For bromine, helium, neon, argon, so I have 4s2, 4p5 and so on. If you just see, so d orbital also gets filled, students. If coming to the last f orbitals also gets filled, but you just remember the outer core, that's it. The element which comes in which period, you have to remember that, followed by this 4s, 4p, or in general ns2, np5. So they contain 7 electrons in their outermost valence shell. Next, if I move on to the next periodic property, an atomic size, or you can also say something on ionic size also you can take. If you compare these, students, you know that what exactly is atomic size. See, atomic size is nothing but it is the distance from the nucleus to the valence shell which contains electron. Now you have studied the things in detail in your very first PUC, isn't it? So in this case, so all these halogens, they have smallest size. Where exactly? In their respective periods. So their size will be very, very small. Suppose if I start from lithium, beryllium, boron, etc., if I move to fluorine and then comes neon, isn't it? Or if I take sodium, magnesium, aluminium, etc., if I take to chlorine and then argon. Now if you compare in these one, if I move like this, that is moving across a period, what happens? The electron will enter into the same shell, effective nuclear charge increases, and hence automatically the size decreases. And hence in a respective period, these halogens have the smallest size. But if you come down the group like this, fluorine, chlorine, bromine, iodine, if you come down like this, what happens, students? The electron enters into the new shell, that is principal quantum number increases, because you know, see, it is 2s, 3s, 4s, and then I have 5s, 6s as such. So with the increase in the number of shell, what happens? The distance from the nucleus to the valence shell also increases, and hence the size automatically increases. So if I just write down the group, if I come down the group, at that instance size, it may be atomic or ionic size, that decreases. So I hope you are clear with these 2 points. So one on electronic configuration and second on atomic size. Next we shall move on to the next periodic property, which is nothing but ionization enthalpy. Fourth, ionization enthalpy or ionization energy, something as such. Now students, what exactly is ionization energy? Ionization energy is the energy, minimum energy, which is required to remove an electron whichever is present in the outermost valence shell. Okay. So from an isolated neutral gaseous atom, it is all there, you know all those things. Now see students, I have NS2-NP5 configuration for this one. Now is it very easy to remove an electron from these things? No, they are one electron short, that's it, correct? So in that case, the ionization energy values, i.e. they are usually high. They do not lose electrons, or tendency to lose an electron is very, very less. On the other hand, they readily accept electrons. So in that sense, the ionization energy will be high. But if I come down the group, what happens? So the size automatically increases and the value usually decreases. I hope you are clear with these points, because these variations you have already studied in your first year. Next periodic property is electron gain enthalpy. Now if you see something on electron gain enthalpy is generally nothing but the energy change or enthalpy change. It may be the amount of energy released or amount of energy absorbed whenever you are adding an electron to the outermost valence shell of that isolated neutral gaseous atom. Now in this case, see, I have NS2-NP5 configuration. If I add an electron to this +1 electron, what they do? They readily accept electron. Yes, I want 1 electron so that I become stable. So after gaining an electron, they achieve noble gas configuration NS2-NP6, and they attain stability by this noble gas configuration, and hence they readily accept electron. Readily accept electrons. So and hence they have large negative electron gain enthalpy values. You might be knowing this. Last year in detail you have studied, so I am not going to say much regarding that. So the value is negative in the sense energy will be released when an electron is added to the outermost valence shell of that particular atom. Now if you just see what happens when I come down the group, you know the variation is very much similar to that of your ionization enthalpy. If I come down the group, so the value will decrease. So here students, you have an anomaly here, or one extraordinary point is seen over here, that is electron gain enthalpy of fluorine. So this will be less than electron gain enthalpy of chlorine. Or you might be knowing that the element which has got highest electron gain enthalpy is chlorine. So this has got the highest electron gain enthalpy, EGE. Okay. Now why? Yake. So for this you already know students, fluorine has an electronic configuration of 2s2 2p5, while chlorine has got 3s2 3p5, isn't it? These things you have studied in detail first year, but I will just say these things. If you see here students, if we are adding an electron here, I will add one electron, plus one electron in both cases, plus one electron. Now in the case of fluorine, the added electron will enter into the 2p orbital. On the other hand, in the case of chlorine, the added electron will enter into the 3p orbital. Now which has got the smallest size? So fluorine, because of the smallest size here, see you are adding electron. Do they like each other? Negatively charged species, they do not like each other. What happens? They repel one another. On the other hand, in the case of this chlorine, size is bit bigger, there is some space. So here also repulsion is seen, but in comparison to that of fluorine, it is very, very less. So in that case, the added electron will suffer more inter-electronic repulsion, and hence less amount of energy will be released whenever you add an electron to fluorine. But here it will suffer no problem, but that is manageable, releasing bit higher amount of energy. So I hope you are clear with these 2 points, so which you have already studied in your first year. So this is regarding the next periodic property on electron gain enthalpy. We shall move on to the next one. The next periodic property is electronegativity. Now what is electronegativity? Electronegativity is generally a tendency of an element. What is that tendency? To accept pair of electron towards itself. Now these halogens, they all are highly electronegative. So they have a tendency to attract that electron towards itself. Why? Because they need electrons, isn't it? So they attract electrons, among which fluorine is the most electronegative element. And the values of this electronegativity also decreases down the group, that you already know. So these are the few periodic properties, students. Okay. Next, I shall move on to physical properties. Now, what are the physical properties, whichever is important to us in the case of this group 17 elements? See, in this case, so I have many physical properties. So first we shall take something on physical state. Now in the case of physical state, students, chlorine, I will make it as Cl2, and fluorine, F2, they exist as gas, because you know they are diatomic, and hence they generally, this fluorine and chlorine will exist as gas, while bromine will exist as a liquid, and iodine will exist as a solid. So this is regarding their physical state or appearance as such. Next, if I move on to the melting point and boiling point, What generally happens in this melting point and boiling point? If you come down the group, generally atomic number increases and hence they increase. The value of melting point and boiling point increases from fluorine to iodine. That is due to the increase in the atomic number. Now, they all are colored. That is, they show color. Now, why do they show color? They have the ability to accept electrons. That electron will move into the higher energy levels or that gets excited, and hence while coming back to the ground state, that extra amount of energy is given out. So, that is usually seen in the visible region, and we have certain colors to these halogens. In that case, fluorine is yellow in color, chlorine is greenish yellow, bromine Br2, so this is red, and iodine violet. So, you might have seen these things in your practicals while doing an experiment with the MnO2. I do not think so now we do that. You can just check, greenish yellow gas will be liberated. If you try with bromine water, so bromine is a dark red colored liquid. If you just dilute it and do it bromine water, that color of bromine water will go whenever you add an unsaturated molecule, something as such. Iodine is generally violet in color. Okay. That is, they have the ability to absorb radiations in the visible region, and hence they impart different colors. Okay. Next, if I move on to certain properties given over here, one with the reaction with water is given to you. So, with water, usually fluorine and chlorine, they react with water. A bit detail have been given to you in chemical property, students. I shall explain you there. On the other hand, bromine and iodine, their reactivity is less, but generally they are sparingly soluble in water. Sparingly means halfway, partial solubility, ardhambarda anta heltaralla hage. So, they are sparingly soluble in water. But where, in which are they soluble? But they are soluble in organic solvents like benzene, carbon disulfide, CCl4, that is carbon tetrachloride, etc., and some other hydrocarbon solvent as such. Okay. Now, in this case, students, one point very important is bond dissociation enthalpy. So, this point is very important over here. Now, what exactly is bond dissociation enthalpy? It is very simple. I have a bond, I want to break the bond, or I need some energy, isn't it? That energy is bond dissociation enthalpy. Now, if you compare the bond dissociation enthalpy of this one, FF, and Cl bond Cl. So, I want to break this bond, I want to break this bond. Now, which might be more or which might be less? So, if you just think about that, you might say this has got small size. So, I have to break that bond, means requires high energy. On the other hand, here it is of bit bigger size, it requires slight less energy, isn't it? No, you are wrong, students. In this case, the bond dissociation enthalpy of fluorine is less than the bond dissociation enthalpy of chlorine. That is, FF bond dissociation enthalpy is very low. So, this is low. Now, you may have a question, why it is low? See, the explanation is very simple. Now, in the case of this fluorine, you know that it is formed by a covalent bond. Last year, Lewis dot structures, you already know that. So you will form a bond like this, isn't it? Now how many lone pair of electrons are there? So I have 3 pairs or 6 electrons on each fluorine atom. So what will they do? They repel with one another. Due to this small size of fluorine and more repulsion, they easily break the bond between 2 fluorine atoms. Even here also it is there, but in comparison with the size, this chlorine is bit of larger size. Okay, so I hope you are clear with the points. In the case of this fluorine, there is more electron repulsions from this lone pair of electrons present on fluorine, which makes it to break the bond easily or making it to have a low bond dissociation enthalpy, which is not seen in chlorine. Okay. If you move on next one, so the bond dissociation enthalpy of chlorine is more than that of bromine, which is still more than that of iodine. After that, but least is for this one. Fluorine has got least. This is one anomalous property of fluorine, can also be said like this. Okay. So this is regarding some physical properties. So I have said something on the physical state. I have said something on the color, melting point, solubility or reactivity with water, and lastly the bond dissociation enthalpy. Next step, we shall move on to some of the chemical properties. Said earlier was very simple aspect, and the major you have already studied in your first PUC or in the previous sessions of group 15 and group 16 elements. Just simple. Now if I move further for chemical properties, so these points are important. Or you can say that these are entirely different from those of group 15 and group 16 elements. We do not say any connectivity or something as such. Now in this chemical properties, so first I shall have oxidation states and trends in chemical reactivity. Now you know what exactly is oxidation state. I have already said that they have the general electronic configuration of NS2 NP5, isn't it? Now if you add an electron or if you remove an electron, we end up with different oxidation states. Now if you just see here in this case, students, it is very simple that if I add one electron to this, they accept an electron and they become NS2 NP6. I have a common oxidation state of -1. I will end up with -1, and we know that they all are electron negative. A -1 oxidation state is the common oxidation state. Now instead of this -1, they also have the tendency to form variable oxidation states like +1, +3, +5 and +7. They can form these many oxidation states. Now you may have a question, how? We already know that we end up with these positive oxidation states whenever we remove an electron from that valence shell. You know that, and I have said that they are not ready to remove the electron. Now I am also saying that they exhibit these variable oxidation states, but how? So in order to explain this, we have to draw the box diagram of electronic configuration. So I have NS, NP, and we will take some ND also. Now students, in general, so here I have NS and this is NP. In general, so 2 electrons in NS, that is NS2, NP, first everything will be singly occupied and then pairing will start. I have totally 5 electrons. Now how will I get this -1? So here I have only single electron, it should be +5. Now see, I have, if I remove this electron, if an electron is removed from here, so I will end up with +1 oxidation state. On the other hand, if I add one electron, plus one electron, if I add an electron, I will end up with minus 1 oxidation state. I hope you are clear with this. Okay. Now, this is in the ground state. This one in the ground state. If I move to the first excited state, I will move to the first excited state. How do we get the first excited state? This is ND, students, I did not write that. Okay, so I have 2 electrons here. See now, in the first excited state, what happens is, you know that during excitation an electron will jump from one particular orbital to the higher energy orbital. Okay. Now, in this case, one electron will shift to this D. So, I have shifted this electron to here. I will shift it here. Now, if you compare the number of unpaired electrons, eshtiде 1, 2, 3. I hope you are clear. See students, illi nanu ground state nalli electronic configuration na tagondidene. Ground state nalli electronic configuration annu tagoluvaga ns2 np5 configuration irtade. So 2 electron in the S, p nalli 5 electron irutte. One single electron anna tegidre I will end up with plus 1 oxidation state. ಅದೇ ಥರ ಒಂದು ಸಿಂಗಲ್ ಎಲೆಕ್ಟ್ರಾನನ್ನು ಸೇರಿಸಿದರೆ ಐ ವಿಲ್ ಎಂಡ್ ಅಪ್ ವಿತ್ minus 1 oxidation state. ಸೊ ಈಗ ಅದೇ ಈ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ನಲ್ಲಿ ಇದ್ದಿದ್ದನ್ನೇ ನಾನು ಫಸ್ಟ್ ಎಕ್ಸೈಟೆಡ್ ಎನರ್ಜಿ ಲೆವೆಲಿಗೆ ಕರ್ಕೊಂಡು ಬರ್ತಾನೆ. ಅಂದರೆ ಈ ಪಿನಲ್ಲಿ ಇರುವ ಒಂದು ಎಲೆಕ್ಟ್ರಾನನ್ನು ಎಕ್ಸೈಟ್ ಮಾಡಿ ಡಿಗೆ ತಗೊಂಡು ಹೋಗ್ತಾನೆ. ಹೀಗೆ ಡಿಗೆ ತಗೊಂಡು ಹೋದಾಗ ಐ ಹ್ಯಾವ್ 1, 2, 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಸಿಂಗಲ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರೋದು. ಜೋಡಿ ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ತೆಗಿಲಿಕ್ಕೆ ಕಷ್ಟ. ಸಿಂಗಲ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕ್ಯಾನ್ ಬಿ ರಿಮೂವ್. ಸೊ I end up with plus 3 oxidation state. Aita, if I just continue, first excited state ig bantu, if I move on to the second excited state, same scenario or same drawing. So I have 2 electrons here. See, in the case of third excited state, what I do is that 2 electrons whichever are present here will be, among this one will be shifted to the D. So hage shift madidre enaitu, I am left out with 1 electron each in these 2. So ಈಗ unpaired electrons ಅನ್ನು ನೀವು count ಮಾಡಿದರೆ 1, 2, 3, 4, 5. So I will end up with plus 5 oxidation state. ಇನ್ನು ಲಾಸ್ಟ್ ಇನ್ನೂ ಅಲ್ಲಿ ಪ್ಲಸ್ 5ಗೆ ಮುಗಿಲಿಲ್ಲ, ಪ್ಲಸ್ 7 ತನಕ ಹೇಳಿದ್ದೇನೆ. ಸೊ ಪ್ಲಸ್ 7 ತನಕ ಬರಬೇಕು ಅಂತಂದರೆ ಏನು ಬರೀಬೇಕು? ಐ ಹ್ಯಾವ್ ಟು ಮೂವ್ ಟು ದ ಥರ್ಡ್ ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್. ಹೀಗೆ ಶಿಫ್ಟ್ ಆದಾಗ ಸೊ which contains 7 single electrons. If you remove all those 7 single electrons, I shall end up with plus 7 oxidation state. Okay, so idu oxidation states hege bantu annodanna helidene. See, among which most common oxidation state iruvantadu -1 only. But extraordinary cases nalli elements can also form plus 1, plus 3, plus 5 and plus 7 oxidation states also. Okay. Now, in the case of fluorine, so fluorine will show only -1 oxidation state. So fluorine ಸಿಕ್ಕಾಪಟ್ಟೆ ಎಲೆಕ್ಟ್ರಾನ್ ನೆಗೆಟಿವ್ ಆಗಿರೋದ್ರಿಂದ ಇದು ನಾನು ಎಲೆಕ್ಟ್ರಾನನ್ನು ಕಳ್ಕೊಳ್ತೇನೆ ಅಂತ ಹೇಳುವುದಿಲ್ಲ. ನನಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬೇಕಪ್ಪ, ನಾನು ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಡಲಿಕ್ಕೆ ರೆಡಿ ಇಲ್ಲ ಅಂತ ಹೇಳ್ತದೆ. ಆ್ಯಂಡ್ ಹೆನ್ಸ್ ಇಟ್ ವಿಲ್ ಶೋ ಓನ್ಲಿ -1 oxidation state. Remember students, no other oxidation states are seen for fluorine. So ಉಳಿದ ಎಲಿಮೆಂಟ್ಸ್, ದಟ್ ಈಸ್ ಕ್ಲೋರಿನ್, ಬ್ರೋಮಿನ್, usually chlorine, bromine and iodine, they show these oxidation states. ಎಲ್ಲಿ ತೋರಿಸುತ್ತೀವಿ ಇವಾಗ? ಸಿ ಎಲ್ಲ ಕಡೆನೂ ಈ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸನ್ನು ತೋರಿಸೋದಿಲ್ಲ. ದೇ ಆಲ್ಸೋ ಶೋ ಮೆಜಾರಿಟಿ -1 ಓನ್ಲಿ. ಬಟ್ ವೆನ್ ರಿಯಾಕ್ಟಿಂಗ್ ವಿತ್ ದ ಸೇಮ್ ಅನದರ್ ಹ್ಯಾಲೋಜನ್, ಇನ್ನೊಂದು ಹ್ಯಾಲೋಜನ್ ಜೊತೆಗೆ ರಿಯಾಕ್ಷನ್ ಆದಾಗ ಇರಬಹುದು, ಅಥವಾ ವೆನ್ ರಿಯಾಕ್ಟಿಂಗ್ ವಿತ್ ಅನ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವ್ ಎಲಿಮೆಂಟ್ ಲೈಕ್ ಆಕ್ಸಿಜನ್. ಸೊ ಅದೆಲ್ಲಿ ಬರುತ್ತೆ ಅಂತಂದರೆ ಇಂಟರ್ ಹ್ಯಾಲೋಜನ್ ಕಂಪೌಂಡ್ಸ್ ಆಗಿರಬಹುದು, ಆರ್ ಯು ಕ್ಯಾನ್ ಸೇ ಸಮಥಿಂಗ್ ಆನ್ one more is oxo acids. So, ಆ instance ನಲ್ಲಿ these chlorine, bromine and iodine may form the oxidation states of this one +3, +5, +5 and +7, +1, +3, +5 and +7. So, we shall see some of these things while saying something on oxo acids of chlorine. Okay. So, with this I hope you are clear. General oxidation state ಇರುವಂಥದ್ದು -1, ಫ್ಲೂರಿನ್ ಯಾವಾಗಲೂ -1 being more electronegative, ಅದು ಒಂದು ಪಾಯಿಂಟು. ಇನ್ನೊಂದು ಸಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ಐ ಹ್ಯಾವ್ ಸೆಡ್ NS, NP and ND. Now, do I have this ND orbital in P? In F ನಲ್ಲಿ ಅಥವಾ ಫ್ಲೂರಿನ್ನಲ್ಲಿ D ಆರ್ಬಿಟಲ್ ಇದೆಯಾ? ಅದು D ಆರ್ಬಿಟಲ್ಲೇ ಇಲ್ಲ ಅದರ ಹತ್ರಕ್ಕೆ ಇರೋದು ಎರಡೇ, ಒಂದು 2s ಮತ್ತೊಂದು 2p ಮಾತ್ರ. ಸೊ ಹಾಗಾಗಿ ಈ ಥರ ಇವರನ್ನೆಲ್ಲ ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡಿ ಮುಂದಿನ ಲೆವೆಲಿಗೆ ಕರ್ಕೊಂಡು ಹೋಗ್ತೀನಿ ಅಂತಂದ್ರೂ ಕರ್ಕೊಂಡು ಹೋಗಲಿಕ್ಕೆ ಅದರಲ್ಲಿ D ಇಲ್ಲದೆ ಇರೋದ್ರಿಂದ it will show only one oxidation state of -1 only. Remember this. Okay. Now, continuing in this one, after this oxidation states, now if you just see something on reactivity towards metal. So, they all are highly reactive. They usually form corresponding halides. Okay. When treated with metals, they end up with metallic halides, or treated with non-metals also they may end up with non-metallic halides, which the study is there bit later. I shall tell you in the later. Now, after this we already know that they have a tendency to accept electrons. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ತಗೊಳ್ಳುತ್ತೆ ಅಂತ ಗೊತ್ತಾಯಿತು. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ತಗೊಳ್ಳುತ್ತೆ ಅಂತ ಹೇಳಿದಾಗ ಏನು ಮಾಡ್ಬೋದು ಅದು? ಸೊ ದೇ ಜನರಲಿ ಆ್ಯಕ್ಟ್ ಆಸ್ ಗುಡ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ಸ್. Oxidizing property. So, since they readily accept electrons, they are used as good oxidizing agents, among which fluorine is the strongest oxidizing agent. Now, this is strongest anta hege gottagate. See, the fluorine can oxidize halides itself, halide ion. So, equations are given to you here. See, this F2 will treat with a halide ion, that is X minus, and it gets converted to F minus and X2. If you balance, inorganic chemistry nalli unbalanced equations ಗೆ marks illa, so ಹಾಗಾಗಿ ನೀವು balance ಮಾಡಬೇಕು. I have F2 ಇದೆ ಇಲ್ಲಿ, so this becomes 2F minus, and I have X2 here, and this becomes 2X minus. Now, what may be the value of this X? So, in this case the X can be Cl, Br or I. ಅಂದರೆ ಫ್ಲೂರಿನು ಉಳಿದ ಹ್ಯಾಲೈಡ್ ಅಯಾನ್ಗಳನ್ನು ಆಕ್ಸಿಡೈಸ್ ಮಾಡುವಲ್ಲಿ ಯೂಸ್ ಮಾಡುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಯು ನೋ ಆಕ್ಸಿಡೇಷನ್ ಹೆಂಗಾಯಿತು ಅನ್ನೋದು ನಿಮ್ಗೆ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ಇದು -1 ಇಂದ ಇಟ್ ಹ್ಯಾಸ್ ಗಾನ್ ಟು 0. there is an increase in the oxidation number. ಹಾಗಾಗಿ ಇದು ಆಕ್ಸಿಡೈಸ್ ಆಯಿತು, ಯಾವುದು ಹ್ಯಾಲೈಡ್ ಅಯಾನ್ ಆಕ್ಸಿಡೈಸ್ ಆಯಿತು. ಅದನ್ನು ಆಕ್ಸಿಡೈಸ್ ಆಗಲಿಕ್ಕೆ ಸಹಾಯ ಮಾಡಿದ್ದು ಫ್ಲೂರಿನ್, ಆ್ಯಂಡ್ ಹ್ಯಾನ್ಸ್ ಫ್ಲೂರಿನ್ ವಿಲ್ ಆ್ಯಕ್ಟ್ ಆಸ್ ಅನ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್. ಸೊ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಏನು ಮಾಡುತ್ತೆ, ವಿಲ್ ಟೇಕ್ ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನ್, ಇದು ಎಲೆಕ್ಟ್ರಾನ್ ಕಳ್ಕೊಳ್ತು, ದಿಸ್ ಶುಡ್ accept electrons and it is becoming F minus. So similarly you can write for others also. If I take a chlorine here, in order to say something on oxidizing property of chlorine, I will have same set of equations. X minus will end up with 2Cl minus plus X2. Now in this case the value of X except fluorine agudilla, fluorine ನಂತರದಲ್ಲಿ ಬರುತ್ತೆ. So only two options ಉಳ್ಕೊಳ್ತು, which is Br and I. Now the last case for Br2 ಗೆ X ಅಂತ ಬರೀಲಿಕ್ಕೆ ಇಲ್ಲ, ಯಾಕೆ I am left out with only one, I ಮಾತ್ರ ಉಳ್ಕೊಂತು. So direct I ಬರೀತೀನಿ. So I minus will end up with 2Br minus plus I2. So this is one reaction which shows that these halogens are good oxidizing agents, or they are the strong oxidizing agent. So this oxidizing property can also be told in terms of reactivity with water. So ನಾನು ಅಲ್ಲೆಲ್ಲ ಒಂದು ಸ್ವಲ್ಪ ವಾಟರ್ ಬಗ್ಗೆ ಹೇಳಿದ್ದೆ. So we will see those equations now. So oxidizing property which can be told in terms of reactivity with water. Now if I take fluorine, so fluorine will oxidize water. Water is nothing but H2O. So this is oxidized to HF and O2. Okay, you have to balance this. So I have single O, but here I have O2. So idanna nanu double ಮಾಡ್ಕೊಳ್ತೇನೆ. So 2 into 2, 4. So 4 HF. So F4 ಆಯಿತು 2F2. Now what has this? Fluorine has oxidized water to oxygen. ನಿಮಗೆ ಡೌಟ್ ಇದ್ದರೆ, so hydrogen ಯಾವತ್ತು +1, so -2. This oxygen is -2. Here it is 0. So from -2 to 0, there is an increase in oxidation number, and hence it is oxidized. So fluorine from 0 to -1 electron ಅನ್ನು accept ಮಾಡಿಕೊಳ್ತು. There is a decrease in oxidation number, and hence it has undergone reduction, or fluorine will act as an oxidizing agent. See, fluorine water ಅನ್ನು oxidize ಮಾಡ್ತದೆ. So water is oxidized. On the other hand, chlorine ಮತ್ತು bromine ಅನ್ನು ತಗೊಂಡ್ರೆ they react with water. So in general I will write X2. So this will react with water to form HX and HOX. So I generally end up with the hydrohalides, that is hydrohalic acid, ಇನ್ನೊಂದು hypohalous acid ಬರ್ತದೆ, this one, where this value of X is generally ClBr. So I end up with hydrohalic acid ಒಂದಾದರೆ ಇನ್ನೊಂದು hypohalous acid. So two products. So this is the oxidation ಅಂತ ಏನಿಲ್ಲ, they simply react to give two different products. The equation is self-balanced. So you no need to balance it again. So I have said something full of fluorine ಆಯಿತು, chlorine ಮತ್ತು bromine ಆಯಿತು. So what next? I am left out with iodine alone now. See, iodine ಮತ್ತು waterಗೂ there is no, the reaction ಅಥವಾ ಈ oxidizing property ಏನಿದೆಯಲ್ಲ, this is non-spontaneous. That is, it cannot be possible at the given conditions of temperature and pressure and general conditions, but it is usually seen as the reverse of this one. ಅಂದರೆ ಏನಾಗುತ್ತೆ? So oxygen is generally that is I minus, iodide will be oxidized by oxygen. So which is generally the opposite reaction of fluorine. So I have I minus here, that will react with oxygen. Usually this requires acidic medium, and hence I have H plus. So I end up with I2 and H2O. So if you balance this, so I have here also this is the same way, 2H2O, and here I have 4H plus. So I2, 2I2 and 4I minus. Or if you can just club it, students, even you can write it as 4HI, even you can write this also. So here I have skipped that and I have given it, I have not written it in the ionic equation, I have written in the molecular form only. So I hope you are clear with these 2 points. So oxidizing property ಎರಡು ಥರದಲ್ಲಿ ಹೇಳ್ಬೋದು, ಒಂದು halide ion ನಲ್ಲಿ, ಇನ್ನೊಂದು with water. So fluorine will oxidize water, ಆದರೆ chlorine ಮತ್ತು bromine react ಆದರೆ iodine reactivity non-spontaneous ಆಗ್ತದೆ, but iodide ions will be oxidized by oxygen in acid medium to form iodine. So this is regarding the oxidizing property of those halogens. Next we shall move on to reactivity with the hydrogen. How does they react with hydrogen? The second one, reactivity with hydrogen. So they all readily react with hydrogen, but a tendency to react with hydrogen decreases from fluorine to chlorine. They generally react to form hydrogen halide in general, that is hydrogen fluoride, chloride, bromide, etc. But these hydrogen halides, they are soluble in water, so forming hydrogen hydrohalic acid. We say, right, hydrochloric acid, hydrobromic acid, hydrofluoric acid, etc. as such. Now, if you say something regarding their acidic strength, so I have HF, HCl, HBr, HI. Okay. So ಸಾಮಾನ್ಯವಾಗಿ ಹೈಡ್ರೋಜನ್ ಜೊತೆ ರಿಯಾಕ್ಷನ್ ಆದಾಗ ಹೈಡ್ರೋಜನ್ ಹ್ಯಾಲೈಡ್ ಅಂತ ಬರುತ್ತೆ, that is usually in the form of gas. So that is usually soluble in water. ಹಾಗೆ ಬಂದಾಗ ನಮಗೆ ಹೈಡ್ರೋಹ್ಯಾಲಿಕ್ ಆಸಿಡ್ ಬರುತ್ತೆ. ಆಸಿಡ್ ಅಂತ ಹೇಳಿದ್ದೀನಿ, ಸೊ ಹಾಗಾಗಿ acidic strength, which is the strongest acid now, HF, HCl, HBr, HI. Now in order to say this, the strongest acid ಅಂದರೆ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ, which should give H plus readily. H plus ಬೇಗ ಬಂದುಬಿಡಬೇಕು. ಸೊ ಯಾವುದರಲ್ಲಿ ಬೇಗ ಬರುತ್ತೆ ಇವಾಗ, which comes. Now if you just see, in order to say that I want to break this bond, in general I will take HX. So ಈ HX ಬಾಂಡನ್ನು ನಾನು ಬ್ರೇಕ್ ಮಾಡಿ I will end up with H plus and X minus. So this is nothing but bond dissociation enthalpy. So ಇವಿಷ್ಟಕ್ಕೆ ನೀವು ಕಂಪೇರ್ ಮಾಡಿದರೆ which bond will break faster? If you just compare that, this will break faster, or this will, HI have low bond enthalpy. So HI ಗೆ bond enthalpy value ತುಂಬ ಕಡಿಮೆ, because hydrogen size ಅಷ್ಟೇ ಇದೆ, but iodine size is so big. Now I can easily break the bond. HF, F small, so I can't break that bond. It is still more in Cl still, but HI is the largest, or I size ಸಿಕ್ಕಾಪಟ್ಟೆ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ I can easily break the bond between that hydrogen and iodine, making iodine, that is hydroiodic acid, as a strongest acid. So ನೀವು acidic strength ಬರೆದ್ರೆ HF is less acidic than HCl, which is less acidic than HBr and HI. So the strongest acid is HI. So this is strongest. ಯಾಕೆ ಇದು strongest acid ಆಗ್ತದೆ? Because of its low bond dissociation enthalpy. Okay, I hope you are clear with these things. So this is regarding reactivity with hydrogen. Next, reactivity with oxygen is there. Third one, reactivity with oxygen. So almost all of them will react with oxygen to form corresponding oxides. So in that, fluorine will react to give only 2 oxides. So one OF2 and another O2F2. So among which this OF2 is stable. O2F2 is not that stable as such. So ಇದನ್ನು ನೇಮ್ ಮಾಡಬೇಕಾದ್ರೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ಫಾರ್ಮೇಷನ್ ಆಕ್ಸೈಡ್ ಅಂತ ಹೇಳಿದ್ದಾನೆ, ಆದರೆ ಆಕ್ಸೈಡ್ ಅಂತ ನೇಮ್ ಮಾಡೋದಿಲ್ಲ, ಬಿಕಾಸ್ ಯು ನೋ fluorine is most electronegative than oxygen. So ಹಾಗಾಗಿ they are named as oxygen fluorides only. So this is oxygen fluoride and dioxygen difluoride, or oxygen difluoride, like this. So they are not said as oxides. Only 2 oxides for fluorine, OF2 and O2F2, they are good fluorinating agents. Okay, they are used in fluorinating agents, especially in the nuclear reactors. They are used as fluorinating agents. Next elements, that is chlorine, bromine and iodine, they react with oxygen, but reactivity generally decreases, and hence they usually form variable oxides showing many oxidation states. Suppose if I take for chlorine, the oxides for chlorine are, so I have Cl2O, ClO2, Cl2O6 and Cl2O7, these things. So we can see variable oxidation states, +1, +3, +5, +7 oxidation states are readily seen in these things. So they all are highly reactive, and they are generally, they usually explode, and hence they are not much used. And this one, ClO2, this is used as a bleaching agent. You might be knowing bleaching, so ClO2, okay, ClO2. So this is used as a bleaching agent, and almost all of them, they will be acting as a good oxidizing agents. Next, if I go for bromine, that is oxides of bromine. So, 3 oxides are given to you, Br2O, BrO2 and BrO3. So, they are also good oxidizing agents. So, in which they are not that much stable, the stability is very, very less. They are usually stable at low temperatures. Okay. Then last for iodine, so I have certain I2O4, I2O5 and I2O7. So, they are also good oxidizing agents, and they are usually solids in nature, and hence in this one that is I2O5, this is used in the estimation of carbon monoxide, CO. They also act as good oxidizing agents. So, do remember this one point, students. These are not that the thing, but just remember these are the oxides in which those halogens exhibit variable oxidation states. This is regarding reactivity with oxygen. Then I am left out with 2 more, one reactivity with metals. So, reactivity with metals, they almost react with metals forming metal halides. Now, in that case of metal halides, one particular reaction is given to you with bromine. M plus Br2 will give you MBr2, where M is generally taken as monovalent, andre single valency, M plus 1 oxidation state nalli iddu tagondiddu. Usually these whatever those metal halides, they are usually covalent in nature. Usually their ionic property also decreases from fluorides, chlorides, something as such. If the metal has a tendency to form variable oxidation states or more than one oxidation state, so in that case the metal ion which is having more oxidation state is more covalent. For example, nanatra SnCl4 ide and SnCl2 ide anta madkoli. Now in this case you can easily calculate tin illi +4 oxidation state alli irutte, illi +2 oxidation state alli irutte. So metal oxidation state high yavudralli ide, idral high ide. So hagagi idu more covalent agirtade. This is more covalent in nature. Idakke ಹೋಲಿಸಿಕೊಂಡ್ರೆ, so ಇದೇ ಥರ ಸುಮಾರು ಎಕ್ಸಾಂಪಲ್ಸ್ ಬರಿಬೋದು. ಇಫ್ ಐ ಕ್ಯಾನ್ ಟೇಕ್ PbCl2 ಮತ್ತು PbCl4 ಇದೆ, UF6 ಮತ್ತು UF3 ಇದೆ. ಸೊ ಆ ಥರದ್ದೆಲ್ಲ F4 UF4 ಸಮಥಿಂಗ್ ಆ್ಯಸಿಡ್. ಸೊ ಇನ್ ದಿಸ್ ಯಾವ ಮೆಟಲಿದ್ದು ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್ ಎಲ್ಲಿ ಜಾಸ್ತಿ ಇರ್ತದೆ ಅದು ತುಂಬ ಕೋವಲೆಂಟ್ ಆಗಿರ್ತದೆ, ಉಳಿದಿದ್ದಕ್ಕೆ ಹೋಲಿಸ್ಕೊಳ್ಳೋದಕ್ಕೆ ಇದಿಲ್ಲ. ಆ್ಯಂಡ್ ಅಯಾನಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಡಿಕ್ರೀಸಸ್ ಜನರಲಿ ಇನ್ ದ ಕೇಸ್ ಆಫ್ MF. So MF will be greater than MCl, MBr and MI. So this is ionic character kadme aagta hogtade ee instance nalli. This is ionic character decreases in this range. Metal fluorides are less ionic than chloride, bromides and iodides. So one particular reaction which is given to you over here in this case. This is something regarding reactivity with metals. Then last one is reactivity with other halogens over here. Now here it should be divalent, students, okay, small correction and I am extremely sorry. Divalent, one equation given to you is Mg plus Br2 will give you MgBr2. So I am extremely sorry, it should be this one. Divalent, illi divalent ಆದರೆ ಮಾತ್ರ ಇಲ್ಲಿ 2 ಬರಲಿಕ್ಕೆ ಆಗ್ತದೆ, ಇಲ್ಲಾಂದರೆ this formula will be changed. So one example given to you here is Mg plus Br2 will give you MgBr2, this one. So almost the metal, if the metal having a higher oxidation state, in that case the compound will be more covalent in comparison with the another. This one point you should remember. Last one, something on reactivity with halogen, other halogen. So these halogens react with themselves. So they combine with themselves to form an enormous amount of compounds of the type X, X dash, X, X dash 3, X, X dash 5 and X, X dash 7, and these are collectively called as inter-halogen compounds. So in this, where X will be a large size atom, ಅಂದರೆ ಈ ಎಕ್ಸ್ನ ಸೈಜು ದೊಡ್ಡದಿರ್ತದೆ, ಎಕ್ಸ್ ಡ್ಯಾಶ್ ವಿಲ್ ಬಿ ಅ ಸ್ಮಾಲ್ size atom. So you have a detailed study on interhalogen compounds which we will take up in the next sessions, students. So we have left with X, X dash, if they combine with 3, 5 or 7. So remember, X is a large size halogen atom while X dash is a small size halogen atom. So this is regarding general properties of group 17 elements, wherein which I have clearly said more on the periodic properties like ionization energy, electron gain enthalpy, electronegativity and size, atomic size. Some of the physical properties have been told to you and more focus have been given on chemical properties like oxidation states and reactivity towards water, hydrogen, halogen and metals. So with these points I hope you are clear with the general introduction given to you. In the next session we shall take upon some important compounds which come under the family of halogens.